When it comes to segment lengths in circles, there are two formulas associated with those lengths. The first is for chords that intersect in a circle. When the chords intersect, they create 4 line segments. So I have them marked in different colors here. So I've got 2 chords that intersect, but it creates segment A and C out of one line, and B and D out of another line. All right, the segments have a special relationship. So when you multiply the 2 pieces of one line together, it equals what you would get when you multiply the pieces of the other line together. So what that means is the formula is just part times part equals part times part. So it's A times C, if you go back up here, A times C equals B times D. Alright, so these are pieces of the same line. So when we're saying part times part, we're saying parts of the same line equals parts of the other same line multiplied together as well. So what that'll look like is you'll be given a picture with 2 chords drawn in it and numbers or letters associated with the lengths of those chords. So using part times part equals part times part, I would take 6 times 4 and set that equal to 3 times x. So 24 equals 3x, 8 equals x. Alright, this next one has got x's in 2 places on one line. So part times part equals part times part is 10 times 18 is going to equal x times x. Okay, those are all the parts. 10 times 18 is 180. X times x is x squared. Square root of 180 equals x. Works out to simplify down to 6 square roots of 5 equal x. The second formula is for tangents and secants. So parts of these lines are outside the circle and other parts are inside the circle. So to get the length of the whole line, you're going to have to add up the outside part to the inside part. The formula is outside times whole equals outside times whole. So if we take a look here, the outside portion is the portion that lies outside of the circle. The whole length, you've got to take into consideration the inside and the outside portion together. So this is outside, where the whole would start here at the intersection point and go all the way down to where it touches inside the circle. Alright, so if you were setting this up, with this being A and B, and this being C and D, A times A plus B, you've got to add those together to get the whole, equals D times D plus C. Again, you've got to add them together. I want a special note here. This is not A times B equals C times D. Okay, there is addition that has to be done when you're doing each of these. If you're only giving each of the parts, you have to add them together. This is by far the most common mistake made in these problems. Don't let it happen to you. Make sure you're paying attention to whether or not you have 2 pieces of a line that you have to add together, or if you're given the whole piece. So an example of a problem would be something like this. I have 12 sitting outside and 16 inside, 3x outside and 4x inside. So I'm going to use outside times whole equals outside times whole. So here's my outside number, which is 12. And I have to multiply that times the whole length of this line, which is 12 plus 16. Okay, then that equals 3x, because that's the outside, times the whole line, 3x and 4x. So 3x plus 4x. I went ahead and added the 12 and 16 together to get 12 times 28. Some people are so used to distributing when you see these parentheses that they'll distribute first before they add. Either way, you get the exact same number. It really doesn't matter. I'm going to add together these two, and 3x plus 4x equals 7x. When I multiply 12 times 28, I get 336. Then I have to multiply 3x times 7x. 3 times 7 is 21. X times x is x squared. I divide both sides by 21 and I get 16 equals x squared. X equals 4. In the next example, it has these lines out here which represent the fact that this 8 spans from this endpoint all the way to this endpoint of the segment. So they're giving you the whole length. So again, I do outside times whole. I don't have to add this time because the 8 represents the entire length. Outside times whole. Again, I don't have to add because the x that they give me represents the entire length. So 3 times 8 equals 4 times x. 24 equals 4x. When I divide both sides by 4, x will just equal 6. In this one, I have a secant and a tangent. So in this case, this x value out here represents the outside, but it also represents the whole line. So this is where the line's not broken into two segments. The outside and the whole have the same measure. That is perfectly okay. I'm still going to use outside times whole equals outside times whole. For the top line, the top segment, outside is 10, your whole is 10 plus 18. So 10 times 10 plus 18 equals outside, which is x, times whole, which is also x. So it would just be x times x. And right here I have x is the outside and the whole. So it's going to go in both spots. So 10 times 28 equals x squared. 280 equals x squared. Square root of 280 simplifies down to 2 square roots of 70 equals x. Now, special notice here. These problems are identical. These problems are identical to the angle problems that we've already covered. Please pay close attention to what the problem is asking for. If it's talking arcs and angles, the formula is also going to include arcs and angles. If the problem's talking about lengths of line, that's where we're using the parts and the outsides and the wholes.